Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video I am going to discuss one very important pattern with AWS Step Function and AWS Lambda. Okay, and that is recursion pattern in Step Function to process long running tasks, right? So let's try to understand first why we require this kind of pattern in some particular situation. Okay, so as we know that in our AWS Lambda currently the maximum runtime is 15 minutes, right? Now suppose you are processing a very huge file from your S3 location in AWS Lambda, okay? Then if it exists 15-minute runtime, then obviously you will be getting time limit exceeded issue, right? Or maybe think the situation like this way: you are having an API, you are fetching the data or the response from that API, okay? At a single shot, if you fetch all the complete response, then to process them using Lambda might take huge time and it might again cause time limit exceeded issue, okay? Instead of that, if we implement pagination in our API and if we extract page by page, then every time for a single page, one Lambda will be running, that will be running maybe for 10 minutes or 15 minutes, and then the next chunk or next page will be processed by the same Lambda next time. Like that, if we build the architecture, that will basically split the long running task into small tasks, and that will be efficient because in Lambda itself we can process or satisfy our business requirement, okay? We will not be facing time limit exceeded issue, right? So that's what the problem statement is. If you are facing a situation where you have to handle long running tasks, then you can use this recursive pattern, right? So long running tasks, basically we split by invoking Lambda recursively, and we use the step function to track the state and to implement the stopping condition. As you know, in recursion we are having a stopping condition also, right? So that we can basically implement in AWS step function, okay? So that's the simple architecture. As you can see here, we are starting, then here this Lambda is there. This Lambda will send the response to a choice state, and in choice state we will validate whether the stopping condition is satisfied or not. Suppose stopping condition is complete, okay? This Lambda is sending a variable is complete. If it is true, that means the job is done, the complete process is done. Or else what this will do, this will again call this Lambda, okay? Like that continuously it will be going until and unless Lambda is sending is complete equal to true. Till then this loop will be going, and if this Lambda is sending is complete equal to true, it will go to the next stage. Maybe here you can implement one SNS topic in which this step function will be pushing the message that see, this particular long running task is complete, okay? So like that way we are going to implement recursive pattern, okay? So now let me show you in which context I am going to show you the demo, and that is basically what I discussed earlier in my previous video, that is limit and offset concept in API, right? So I have shown you that this is our base API. All these codes I have already discussed. I'll be sharing the prerequisite link in the description box, you can check. So here we are having an API, okay? Here you can see total there are 5,000 records, okay? The ID is basically primary key, and here you can see maximum ID is 5,000, okay? So what we can do using request module, we can basically pull the complete response at a single shot, all 5,000 records, okay? But that time we might face Lambda runtime issue. So to avoid that, what we have done earlier, we have implemented limit and offset concept for pagination, right? So here we have that functionality. So I can just put, suppose I am putting start equal to 0 and limit equal to 5, then what will happen? I'll be getting first 5 records only. As you can see here, maximum ID is 5, okay? Then next time what I will do, this offset value will be increased by the limit, okay? So currently offset value is 0 and limit is 5. So next time offset will be 0 plus 5, which is 5, right? So if I make offset equal to 5 and then limit also same, I'll be getting next 5 record. You can see here ID is starting from 6 and ID is going to 10, okay? Like that. So here what we can do, we can basically use this particular pagination concept using offset and limit in our AWS Lambda, okay? And here what we can do, each time whenever we'll be fetching the records, we can check the response array length, okay? Because you can see this response is an array, right? Here you can see the square bracket is closed and here square bracket is opened. So based on this, we can conclude that whether we need to further make an iteration or not. If we are getting array length as 0, that means we no need to further iterate, okay? If we are getting array length something, that means next time also we'll be iterating. That's simple concept, right? And that's what I have shown earlier also. Here when I use this particular code in Google Colab, here you can see URL. Each time we were changing offset and limit. So initially we declared offset as 0 and limit as 1000. And next time onwards, what we are doing, we are getting the response. We are checking whether basically amount of extracted data for that array length is 0 or not. If the length is 0, then we are breaking this infinite while loop. Else we are dumping the data in a particular local folder. Okay, with the file name. We are building unique file name based on uuid 4. All this I have explained in detail earlier. And then for the next iteration, we are increasing the offset by offset plus limit. We are updating the offset value, right? So that's how we have implemented pagination. Now what I am saying that this is a long running job. So what we can do, we can split this complete process into two stages. Okay. For the step function, we can give the responsibility for tracking the complete process and to check whether stopping criteria is met or not. Stopping criteria is basically the length of this is 0 or not. Okay. Where we are breaking. So that same thing we will be giving the responsibility to step function. And what Lambda will do, Lambda will just fetch the data and write in a particular S3 location. In Google Colab, when we have written in a local directory. Now, when we are going to use Lambda, that time we will be writing that same in a S3 location. That's the only change. Okay. So let's see our Lambda code without any further delay. Okay. So here what we are doing, we are basically importing JSON, request, uuid and boto3. Boto3 is required to create S3 object. Basically, each time Lambda will be writing the response in a particular location. So for that S3 is used. Okay. And then here uuid is basically used to generate unique name for our files. Request module we are using to fetch the response from the API, and input JSON, json.loads, json.dumps, often we use on our Lambda function, right? So for that we are using, and then this is our Lambda function. Okay, main Lambda function. So what we are doing, we are printing the event. Okay, initially we are making offset equal to 0. Okay, and then here what we are doing, suppose if you are calling for the first time, if you check this image, initially we are starting, we will be putting nothing in this particular input of the step function. So initially what the Lambda will do, the Lambda will consider offset as 0. Okay, so here you can see in the body part, we are basically getting the body. Okay, so if you consider this particular image, when we will be starting our step function in the input, if we don't pass body for the first time, then the body key will not be there in the Lambda event, right? So that's why I am giving event.get body comma 0. That means if body key is there, it will be taking that particular value corresponding to the key body, or else it will be taking 0. Okay, because for the first time this particular key itself will not be there. So that's why I am putting 0, and if body is 0, I am keeping offset as 0. That means offset 0 is what is our starting criteria. Okay, and limit is anyway always going to be 1000 only. Then here we are declaring isComplete equal to false. Okay, so always initially we will be making isComplete equal to false. Later we can update based on our need. Okay, then here we are keeping our URL same as we did earlier. We are printing what URL it is invoking. We are getting the response. We are converting that to JSON, and then here we are getting the length, how much data or how many items it has extracted. Okay, and then if length is not equal to 0, then we are writing that particular response. Whatever data was extracted, we are basically dumping in a S3 location. Okay, and here we are using S3 client, what we have created here, right? Okay, and then here what we are doing, if length of number of extracted records in this current iteration is 0, that means we reached the end stage, we reached the end page, we no need to further reiterate, right? So we are making isComplete equal to true. Okay, so we are just updating the variable, whatever we have initialized as false. If this condition is satisfied, then we are keeping isComplete equal to true. Okay, and in the step function, in the choice state, we will be validating whether isComplete is true or false. If it is true, then it will be going to the next step. If it is false, then it will again call the same Lambda only. Okay, now next time when we will be calling the same Lambda, we need to update the offset value, right? Suppose already in the first iteration itself, I have extracted 10,000 records. Next time I need to skip the first 10,000 records, and next after that from 10,001 we have to start extraction, right? So that's why I am updating the offset, and then here I am basically creating a dictionary. Okay, where I am keeping the offset value and isComplete. Okay, these two key value pair I am putting, and then we are returning this as Lambda response. Okay, body as response JSON set. Okay, so what will happen, this particular lambda will send the step function back this particular response. Okay, so how it will be actually looking, the JSON for the step function in the choice state, it will be coming like this. So body and the response JSON set in body is basically looking like this, right? So basically the complete JSON data for step function in the choice state from lambda function will look like this. Okay, so what we can do, so next time it will go to body, this is the key, and from here it will be getting the offset value. So that's what I basically did here. You can see that if body is not 0, then offset equal to event of body and then offset. Okay, that's how it is working, right? So the complete input will be stored in event, that is basically this one, lambda event, right? And in that event, body is the first key, inside that offset will be there. Okay, so from this offset, next time I have to start running the code. That's how basically the recursion is implemented. Simple. So what I will do, I will go to AWS Management Console, I will go to Lambda, and I am going to use basically Python 3.7 because Python 3.9 the request module is not present. So again I have to create Lambda deployment zip or Lambda layer, etc. So I am just using Python 3.7 because there by default the request module is available. Okay, recursion demo, and here I will create the function, right? All I will do, I will take this complete code, which I'll be sharing in the description box or in the comment section also, and here I will paste in the lambda. Okay, perfect, and I will deploy this. Okay, where I am writing the data, you can see here in S3 we are basically writing in the bucket glue zip. Okay, let me show you in S3. So here this is our bucket. Inside that extract is the folder. Okay, currently no object is present. So there in the glue zip bucket, in the extract / folder, we are basically creating each time new file and we are writing there. Okay, so what we need to do extra, we need to basically give S3 access. Okay, so I will go to permission and I will go to this role. And I will provide S3 access. Right, I'll attach the policy. That is done. And now what we will do, we will go to step function. Okay, so here I can go to create state machine, design workflow visually, that's fine. So first I will invoke the lambda. Okay, so here function name we have to choose. The function name is recursion demo. So this is the one, right? And then we will go to choice state. Okay, so in choice state what we will do, we will basically say in the rule 1, let me edit, add condition. So if this lambda is returning the body, okay, in the body what we'll check isComplete is true or false. Okay, so I will be taking this particular key and $.body. Here this is the isComplete is the one, right? $.body.isComplete, if that is equal to, this is boolean constant, if that is equal to false. Okay, if it is false, what we have to do, if it is false, that means the response whatever we got in the current page, that is basically non-zero. Okay, so we will make a further iteration. Okay, so here I am basically going back to lambda invoke. Okay, so here you can see if $.body.isComplete is false, then again the lambda is invoked. Okay, and when it is again invoked, this lambda second time when it is running, then it is basically getting the offset value from the first lambda run, right? Because in the first lambda run we have given the offset value. Next time when it will be getting called, it will be picking up that particular offset value, and from there it will hit the URL. That's how basically recursion is working, right? And then like that way it will be keep on going. And if body.isComplete is nothing but true, that means the job is complete. So we can, for the time being, I am putting a pass block. Actually here you can put an SNS topic and you can send the notification, okay, that the long running job is completed. And basically we have splitted the long running job using the recursion technique, and every time small chunks are getting processed by small lambda. Okay, so here I can give notify developer like that. Okay, so for the time being this looks good, and then here I will go to next, and here what I will do, I will go to next, and here I can give recursion demo YT, and here I will create this state machine. Okay, and I have to make sure this state machine has lambda execute access. So AWS Lambda execute access is provided. Okay, right. And now what I will do, let's test it out. Okay, so here start execution. See, now in the beginning, in the first call, I am not putting any offset or something. Okay, our code will automatically take the offset value 0 for the first time, right? So here you can see currently Lambda invoke is running. And actually it is completed also. Actually it is completed pretty fast. So let's see, if I go to monitor section and if I go to view logs in CloudWatch, you will understand in better way. Okay, so here see, first when I am basically printing the event in the code, you can see here I am printing the event. I am printing the URL also every time what it is invoked. So that way we will be understanding how it is getting called recursively. Okay, so URL for the current iteration, first time when it is called, you can see start is 0, limit is 1000, right? Next time when it is called, you can see start time, there is offset is 1000, limit is 1000. Okay, so first time because already it consumed the first 1000 records, so next time when it is calling, it is skipping first 1000 records and it is extracting the next 1000 records. Okay, next time when the URL is getting called, it is basically starting the offset value from 2000. Okay, next time it is starting the offset value from 3000, and next time it is starting the offset value from 4000, and next time it is starting the offset value from 5000. Okay, so when it is calling from 5000 to next 1000 records, it is getting no record, right? Because we are having actually total 5000 and which we already consumed, right? So that's why next time here in the choice state when it is going, Lambda will say the process is completed. Okay, so if I go to choice state and if I go to step output, here you can see isComplete is true. Okay, that means the job is completed, and that's why the notified developer team is executed. Okay, so let's see, if I go to S3 location in this particular folder, if I refresh, here you will see that 5 times the pagination happened, and that's why 5 files are created. Okay, let me show you last thing, that these 5 files, whatever we got each time by chunk consumption, that is nothing but same as of the total consumption from our actual API. Okay, and that I can show using Colab notebook. So here what I have done, basically I have installed Spark, then here I have basically taken access key and secret key which is having S3 read access, and then here I am creating the Spark session with the required S3 connectivity jars. Okay, then here what we are doing, we are directly reading the data from this particular S3 location where the Lambda, our recursion has written. From there only we are reading the data. Okay, SDF, and here what I am doing, I am reading the CSV file which is basically storing the actual 5000 data directly downloaded from the website. Okay, in my previous video I have shown how to download that, so that one I am reading. And then here what I am doing, to easy of comparison, I am keeping the column order for both of these two data frames same. Okay, so that we can do subtract and we can check. And here we are doing first data frame subtract second data frame union all second data frame subtract first data frame. Okay, and the count should be 0, which can ensure that both data frame contain same record, right? So let's see. So here we are getting 0. That means what? That means in the actual API call without any offset or limit concept, if we extract the complete response in a single shot, whatever data we'll be getting using this kind of recursive approach also, we we are getting the same thing. Okay, and not only in this kind of pagination for API, but you can basically try to twist our code and apply in many other places also. Whenever you face that your job is taking very long time to complete, then you can basically split your process using offset and isComplete these two key, and basically each time you can call the lambda, which should not take huge time, because using limit you are basically limiting the number of lines or number of items to be processed. Okay, and that way you will never face the timeout issue. Okay, and not only that, I will also provide this particular JSON data. So this JSON data I will be sharing in the description box, so that you can directly paste in your AWS account, and that way directly this particular code block or this step function will be built for you. Just you can change your function name or some other blocks. If you need to add, you can do those kind of modifications. Okay, so that's the power of reusability also. Once you build a step function, save the JSON. That way next time you no need to create the step function from scratch. Okay, right? So I hope you enjoyed this particular recursive pattern. If you find this particular video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now. And don't forget to press the bell icon to get the notification of all latest videos. Thank you.